Hello, my name is Brian Williams. I am studying mechanical engineering at the University of Idaho. I am going to be taking you through the solder reflow process for printed circuit boards. The reflow process is the setting of solder. There are a few necessary parts before reflow ovens that are needed to ensure the process goes smoothly. Lead-free solder paste, stencils, SMT machine, and reflow oven. Prior to 2006, tin lead solder was the norm for any manufacturer to use on printed circuit boards. The restriction of Hazardous Substance Directive, or RoHS, went into action and restricts having lead in electronics sold in the European Union. This has also been adopted around the world. One of the main reasons for the directive was to get hazardous materials out of households and waste centers. Lead-free solder has been replaced with SAC, an acronym for the elemental symbols for tin, silver, and copper. Some other elements that are used in solder are bismuth, indium, and zinc. For your company's needs, assess the potential amounts you'll need because different combinations vary in price and melting temperatures. These temperatures can be within 5 to 20 degrees Celsius above leaded solder, which increases the amount of energy you will consume and affects the baseline of your products. Once your solder paste is decided, you'll need printed circuit board stencils. Getting the right amount of solder paste on the printed circuit board is critical. Features to consider about your stencil are the depth of stencil and the amount of printed circuit boards you'll want to produce at a time. Typically for large printed circuit boards, stencils have one board per stencil, and smaller boards can have multiples of that board on one stencil. The depth stencil is critical in that you do not want to be adding too much or too little of the solder to the soldering pads. The soldering pads are silver or gold pads you see in the pictures. Too much solder will cross the PCB and connect the solder to another pad and will ruin the circuit if it goes all the way through production. It is also called a short circuit. Too little solder will have a bad connection when your components are added to the board at the end of the production and testing is to be conducted on your circuit. This creates rework which can be costly. Best practices to help decide on depth of stencil is to follow the industry recommendation and adjust to the needs of your product. System mount technology, or SMT, are machines that are used to place specific parts on designated pads. Putting these parts on by hand can be done, but some parts are only millimeters big, and SMT has become very efficient with accuracy and speed of placement. The part that picks up and places the components is called the head. There are various head types. They all move in an X, Y, Z coordinate field. The difference is how many components they can pick up, the size of the components, and shape of the components. Many companies use various SMT machines to accommodate the vast variety of components available and how they are needed to be placed on the printed circuit board. After all necessary components are placed, it is time to send the printed circuit board to the reflow oven. These are photos of a typical reflow oven looks like, and the graph of what is called a reflow profile of the temperature seen inside the oven. Ovens have top and bottom heaters that are controlled by a computer program and operator. Each set of ovens' top and bottom heaters are called zones. Ovens can have as little as 6 zones to as many as 12. Longer ovens are typically better for more controlled profiles. They also allow the production line to move quickly through the oven so there is no bottlenecking before the oven. The advantage to having ovens with multiple zones are ensuring the preheat of the solder and wetting of the solder reaches ideal temperatures. This allows the solder to become completely liquidous before it goes through the cool down zone and hardens. Ideal temperatures vary with each solder combination, and each of those combinations require the solder to be liquidous for a minimum amount of time. The minimum liquidous time helps with ensuring the solder is liquidous, and better chemical structure of the solder will have the best connection of the attached component and its pad to the circuit board. The liquid solder also has high viscosity, meaning the solder will only want to stick to itself or like materials, and does not run or bleed out like an ice cube becoming liquid. This is a major benefit because if the SMT placed a component slightly off its designated pad, The solder will pull the component into place and result in a good connection. Bringing the reflow process to a close, I have talked a lot about the pieces and decisions that need to be made before you get to the process. Choosing the right type of solder paste, ensuring the specs on your stencil are meeting your needs, source your components so you'll be purchasing what you need for your SMT machines, and most important, your reflow oven needs to be capable of preheating and wetting your solder. A great working oven means great working product. I hope this has been enlightening to the reflow process and how it involves more than itself. Thank you again, and I am Brian Williams.